In this video, we will see how drift velocity is connected with current. The relation between current and intensity of current and drift velocity. Now, whenever we are providing a field or when we are connecting it with battery, or let's say we are providing a field here, positive. So, the electrons are drifted in leftward direction or along the direction of field. Now, let's say we have total n number of electrons, capital N number of electrons in a conductor. Okay. Then we are going to introduce a new term which is small n, that is nothing but number of free electrons in unit volume. Okay. Because that is a easy measurable quantity. Let's say we are now taking 1 meter conductor. Now it will have a different number of free electrons. When we are making 2 meter road, then that will have different number of electrons. When we are making 3 meter road, then that will have different number of free electrons. So now for easy for the measurement, we will define for unit volume. Now we can get the number of electrons for any amount of volume. Just need to multiply the number of electrons in unit volume with the total volume, right? Now number of electrons in unit volume is small n. Now what is the total number of electron in this case? That is number of electrons in unit volume into volume of this conductor. What is volume? Area of cross section into L. So N into area into L will be, so A into L is basically volume, and N into this will be giving us the total number of free electrons. Now how we will get the total charge of free electron? This many number of electrons into charge of an electron. What is charge of an electron? Minus E. Now the value will be N into A into L. This is the total number of electrons into minus E, that is the total amount of charge. Now a conductor is having this much amount of charge inside. Now let's assume that whenever we are providing an electric field, these electrons are drifted to this direction, leftward direction. So which electron will come out first? This one will come out, then next. So these are moving in this direction, and the last electron will be this one. And let's assume that this electron from this position has reached this position, which means all the other electrons are before this. So all the electrons inside the conductors has already came out of the conductor. So by the time this electron reaches here, all other electrons have came out of the conductor now. Clear? Now let's say, so what is the velocity here? Drift velocity. And let's say if the electrons passes a total displacement from here till here, what is the total time taken for that? If V is the velocity of this electron, and what is the total displacement when it travel from this position to this position? That is nothing but length of the conductor. Clear? And we know from mechanics that displacement is equal to velocity into time. So time is equal to displacement divided by velocity. So here in this case, displacement is L and velocity is drift velocity. So L by Vd. Okay. Now that is the time, and in that time total this much amount of charge have came. That is the total charge have came out. Now how can we get the value of current? Current is equal to Q by T, and we know the value of Q as N A L into minus E divided by what is time? L by Vd. Drift velocity. L will cancel, and what will be the value? N A E V D. See, and there is a negative outside. Clear? And this is the value of current I. Clear? Make a note of it. This is the relation between I and Vd. I and Vd are connected by this equation. I is equal to minus NAE Vd. And see this equation, we have a minus sign here. What does that represent? See, direction of current. Okay, which are the terms that are having direction here? Velocity is having direction here, right? Drift velocity, which is in this direction. Now look at the equation. I is equal to minus NAEVD, which means whatever the direction of drift velocity, opposite to that you will have current, which means whenever drift is happening in this direction of current is in this direction. But that doesn't mean that current is a vector quantity. I will prove it in the next topic. Current is scalar, but direction of current, that direction means like for a flow there will be direction, right? So direction of current can be taken as opposite to direction of movement of electrons or direction of drifting of electron, or basically drift velocity. Thank you.